This video is about the formation of ionic bonds and includes the use of dot and cross diagrams. When a metal atom reacts with a non-metal atom, positive metal ions and negative non-metal ions are formed. There will be an electrostatic attraction between these oppositely charged ions. This electrostatic attraction is strong and it holds the ionic compound together. So we can define an ionic bond as the strong electrostatic attraction between oppositely charged ions. This is a definition that you need to learn, and it is one that is frequently asked about in exams. You may be asked to state the type of bond that exists in a compound that is unfamiliar to you. Remember that if a compound contains a metal and a non-metal, the type of bond will be ionic. Dot and cross diagrams are useful diagrams as they show the arrangement of electrons in a compound or element. As the name suggests, electrons are typically shown as dots from one element and crosses from another. We will use sodium chloride as an example. When an atom of sodium and chlorine react, the outer electron from sodium is transferred to the outer shell of chlorine. When sodium loses an electron, it forms an ion with a 1+ charge, and when chlorine gains an electron, it forms an ion with a 1- charge, which we can show like this. Now both have become stable ions with a full outer shell of electrons. This is the dot and cross diagram for sodium chloride. Note how each ion has square brackets and a charge. It is also really important to remember to show the symbol of each ion. If you don't clearly identify each ion, you can lose a mark in an exam. Just be careful when you draw dot and cross diagrams. There should not be a plus sign between the two ions in an ionic compound. This is a mistake some students make. This diagram shows all of the electron shells, but unless the exam question specifically asks you to show the other electron shells, it is usual to only show the outer shell of electrons, like this. The resulting ionic compound has no charge, so check that your positive and negative charges cancel each other out. The dot and cross diagram can also help construct the formula of the compound. This shows that one sodium ion is needed for every one chloride ion, therefore its formula is NaCl. When you have drawn your dot and cross diagram, check it carefully to make sure that each ion has a full shell of electrons. This is a typical exam question. Lithium is in group 1, so will have 1 electron in its outer shell. Fluorine is in group 7, so will have 7 electrons in its outer shell. So we can show the outer electrons of the two atoms like this. Lithium needs to lose its outer electron to have a full outer shell. Fluorine needs to gain 1 electron to have a full outer shell. So 1 electron is transferred from the outer shell of lithium to the outer shell of fluorine. By putting a dot into the outer shell of fluorine, it shows that this electron has come from lithium. Now a word of caution with lithium. A lithium atom only has 3 electrons, so when it loses its outer electron, it leaves just 2 electrons in the first shell. Remember that the first shell can only hold up to 2 electrons, so it is still full, but you should only show 2 electrons in its outer shell, and not 8 electrons like we did with sodium. Lithium forms a lithium ion with a 1+ charge, and fluorine forms a fluoride ion with a 1- charge. Note how each ion is clearly identified with its symbol, it has a square bracket and a charge, and there is no plus sign between the two ions. 1 mark is awarded for each correct ion. The charges cancel each other out, so the ionic compound has no overall charge. The diagram shows that 1 lithium ion is required for every 1 fluoride ion, and the formula of lithium fluoride is therefore LiF. Remember that you only need to show the outer electrons unless the exam question states otherwise. The previous examples showed how to construct the dot and cross diagrams for ionic compounds formed from group 1 and group 7 elements. You need to know how to draw the dot and cross diagrams to show the formation of ionic compounds from combinations of metals with non-metals from different groups. Magnesium oxide is formed from magnesium, which has 2 electrons in its outer shell, and oxygen, which has 6 electrons in its outer shell. Remember when drawing dot and cross diagrams, we only need to show the outer electrons, unless told otherwise. Magnesium will lose both outer electrons, and oxygen will gain both of these electrons. Magnesium forms a magnesium ion, which has a 2+ charge, and oxygen forms an oxide ion with a 2- charge, and both have a stable full outer shell configuration. When drawing dot and cross diagrams, Make sure each ion is surrounded by square brackets, its charge is shown, and the symbol of each ion is given. There is an electrostatic force of attraction between the negative and positive ions, which is also known as an ionic bond. Magnesium oxide is formed, it has no overall charge, and its formula is MgO. When drawing dot and cross diagrams, double check that each ion has a full outer shell of electrons. Now let's look at a more complex case, where calcium reacts with fluorine to form calcium fluoride. Calcium is in group 2, so has 2 electrons in its outer shell. It will give one of these to an atom of fluorine, which completes the fluorine atom's outer shell. But calcium still has 1 electron in its outer shell. It will give this electron to a second fluorine atom. This results in the formation of a calcium ion with a 2+ charge, and 2 fluoride ions each with a 1- charge. To form a neutral compound, 2 fluoride ions are needed for each calcium ion. Ionic bonds form between the ions and calcium fluoride forms, which has the formula CaF2. When drawing the dot and cross diagram, ensure you draw the correct number of ions of each element. It is important that the negative and positive charges cancel out, so that the ionic compound has no overall charge. When drawing a dot and cross diagram, think about the number of electrons each atom has in its outer shell. Potassium in group 1 will have 1 electron, and sulfur in group 6 has 6 electrons. Potassium will lose its outer electron, which sulfur will gain. Potassium forms an ion with a full outer shell and a 1+ charge. When drawing the dot and cross diagram, remember to show the symbol of the ion and to draw square brackets around the ion with the charge shown. Sulfur still needs to gain 1 more electron, therefore another atom of potassium loses its outer electron, which sulfur gains. This second potassium atom forms a 1+ ion, and sulfur forms an ion with a 2- charge as it has gained 2 electrons. You gain 1 mark for showing the correct number of electrons in both potassium ions and the sulfide ion, and a second mark to show the correct charges. The final mark is to give the formula. As 2 potassium ions are needed for every 1 sulfide ion, the formula is K2S. In summary, ionic bonds are formed between metals and nonmetals. They are the electrostatic attraction between oppositely charged ions. These forces of attraction are strong and hold the ions together. We can use dot and cross diagrams to show how the electrons are arranged in ionic compounds. Don't forget to check out all our other fantastic revision resources here at Save My Exams.